The buzz surrounding the Tesla Model 2 is growing, and for good reason. For the first time, a Tesla car could enter the market with such an aggressive price tag that it could change the game not only for Tesla, but for the entire electric vehicle industry. We're talking about a launch scheduled for November 2026, with a starting price of $15,990. This places the car at an unprecedented level for the company, which has always been seen as a technological benchmark, but also associated with prices beyond the reach of most people. The feeling is that Elon Musk and his team have decided to take a bold step, opening Tesla's doors to the general public, targeting the mass market directly. And this isn't just about selling a car, but about showing the world that it's possible to truly democratize electric mobility. The most interesting thing is that this price range didn't emerge by chance. It's a move clearly designed to head on the advance of Chinese automakers, which already offer affordable electric models with competitive range and features. It's as if Tesla looked at the board and realized that, to stay in the game, it needed to make an unexpected move. The Model 2, with this starting price, can attract not only technology enthusiasts, but also ordinary consumers who, until now, hadn't even considered an electric car as an option. It's a strategy that blends boldness and precise calculation, something that, let's face it, fits very well with Musk's business style. Another curious detail is the timing of the launch. November 2026 isn't just a random date on the calendar. It coincides with Tesla's annual meeting, an event always laden with expectations and industry-shaking announcements. Some predict the Model 2's unveiling will be the most watched moment in the company's history, surpassing even iconic launches like the Model 3. The very idea of unveiling an affordable car at such an event guarantees a global spotlight, making the Tesla name resonate even more strongly in international headlines. But of course, it's not just about launching a cheap car. The public is increasingly demanding and won't accept compromising on quality or user experience just to save on the final price. Tesla seems to know this, and from what's being said, the Model 2 will arrive with a package of features that maintain the brand's technological essence. And that's the key, delivering something that feels like a true Tesla, even while costing less than a popular combustion-powered sedan. It's no simple task, but that's exactly the expectation being created. When it comes to mass-market sales, it's not just price that counts, but also the perceived value. Over the years, Tesla has built an image of innovation, speed, and futuristic design. Bringing this to an entry-level model without it feeling like a cheap Tesla is a delicate challenge. Therefore, many people are curious to see what design, finish, and technology choices the company will make to maintain its prestige while still achieving that $15,990 price tag. It's the kind of dilemma that could determine whether the Model 2 will be remembered as a revolutionary success or as a promise that wasn't fulfilled. It's worth remembering that this price point puts the Model 2 in direct competition with the combustion-powered cars currently dominating the streets. Models like the Toyota Corolla and Honda Civic, for example, cost more than this starting price in the United States, and they don't offer the savings and innovation that an electric car offers. The simple fact that a Tesla costs less than these traditional sedans is already a strong argument for convincing those still on the fence about switching to electric vehicles. And, let's face it, it's hard not to be intrigued by this prospect. There's also the issue of scale production, which will be a decisive factor in keeping the price low. Tesla plans to manufacture the Model 2 in massive volumes, requiring adjustments to the assembly line, new partnerships with suppliers, and possibly factories dedicated exclusively to this model. The strategy is clear. The more units produced, the lower the cost per car, and the greater the competitive advantage over rivals that have yet to optimize mass production of electric vehicles. It's almost a race against time to see who can meet demand first. Tesla intends to take a bold step by debuting a battery technology in the Model 2 that, until recently, seemed far from mass production: aluminum-ion batteries. This change, if confirmed, will be a direct departure from the current standard, in which virtually all of the brand's models rely on lithium-based versions. The proposal is simple to understand but complex to execute. Reduce costs, increase efficiency, and at the same time, eliminate dependence on a material whose price fluctuates like a roller coaster. Elon Musk has long expressed unease with the lithium-ion market, and the Model 2 could be the perfect opportunity to put an end to this volatile relationship. Replacing lithium with aluminum should be a strategic move, not only to reduce the cost of the final product, but also to ensure greater predictability in the production chain. Aluminum is more abundant, cheaper, and has suppliers in several countries, which could give Tesla the logistical security that lithium, dependent on specific regions, never offered. If this transition is truly implemented, it will send a clear message to the market. Tesla will not just follow trends, but set the next standard. And this could generate an immediate reaction from other automakers, which will be forced to rethink their plans. This shift will also bring a powerful narrative appeal. Imagine the impact of announcing that Tesla's most affordable car will be the first to use a groundbreaking technology, potentially safer and more efficient than anything ever on the road. The strategy is smart because, even as the entry-level model, the Model 2 will still serve as a showcase for the brand's future. And as Elon Musk has shown with other launches, he knows how to turn a technical decision into a story that captivates investors, fans, and even those who have never driven an electric car. Naturally, this replacement won't happen overnight. Before reaching end consumers, the aluminum-ion battery will have to undergo extensive testing to prove its performance in real-world conditions. The market has heard many promises about revolutionary technologies that never materialized, and Tesla will have to demonstrate, with numbers and results, that this venture is viable. It's a calculated risk. If all goes well, the Model 2 could redefine what's expected of an affordable electric car. If not, it could face severe criticism for creating expectations that weren't met. Another important point is that this change in battery chemistry could directly impact Tesla's sustainability strategy. Aluminum, being widely recyclable and requiring less energy to be reused, will give the car an even stronger environmental appeal. This could be used as an argument to win over consumers who prioritize environmental impact. In this regard, the Model 2 could gain an advantage over rivals that still rely on rarer materials and controversial extraction processes. The technical advantages promised by aluminum-ion batteries are what's most striking about this story. If actually implemented in the Model 2, they could offer an energy density of up to 500 kWh, twice what most current lithium-ion batteries can deliver. This means that, for the same weight, the car could store significantly more energy, increasing range without the need for a massive battery pack. It's the kind of advancement that can make a compact car behave like a larger sedan when it comes to range, while still maintaining a reduced weight for improved overall performance. Furthermore, aluminum offers clear safety advantages. Unlike lithium cells, which still carry the risk of overheating and fire in extreme cases, aluminum will work with a non-volatile electrolyte that's stable at much higher temperatures. In practice, this means eliminating one of the biggest fears of electric car drivers: seeing the vehicle catch fire after an accident or internal failure. This added safety could help the Model 2 win over consumers who until now have remained loyal to combustion engines precisely because of battery-related concerns. Another aspect that should impress is durability. Laboratory tests already suggest that these batteries can reach up to 10,000 charge and discharge cycles, which, in daily use, would equate to over 20 years of operation without significant loss of capacity. For comparison, most lithium batteries typically reach the end of their useful life between 5,900 and 3,500 cycles, depending on use. If this longevity is confirmed, the Model 2's cost of ownership will be much lower, as the owner won't have to worry about replacing the battery pack anytime soon. Charging efficiency will also be a selling point. Thanks to aluminum's electrochemical properties, energy transfer within the cell should occur more quickly and stably, allowing for faster recharges without degrading the battery. This feature addresses one of the biggest obstacles to the popularization of electric vehicles: waiting times at charging stations. Imagine a car that not only costs less, but also spends less time idle while recharging. It's a combination that directly impacts the user experience. In terms of performance, the weight reduction provided by more efficient batteries should translate into more agile acceleration and improved handling. The Model 2, despite being designed as an affordable vehicle, could surprise with its quick steering response and optimized energy consumption. This lightness will also allow the car to be more economical in daily use, further expanding its advantage over similarly priced combustion-powered models. When it comes to cost, aluminum could truly be a game-changer for the Model 2. The difference begins with abundance. While lithium is relatively rare and concentrated in a few countries, aluminum is about 800 to 1,200 times more common in the Earth's crust. This means Tesla will have many more potential suppliers spread across stable and diverse regions like China, India, and Australia, reducing the risk of supply chain disruption. Furthermore, the average price of aluminum, around $2,200 per ton, is a fraction of what is paid for lithium and, especially, cobalt or nickel, metals that continue to drive up the price of traditional lithium batteries. This cost difference could have a direct impact on the car's final pricing. It's estimated that a 53 kWh aluminum-ion battery pack will cost approximately $2,000 less than an equivalent LFP. In practical terms, this means that instead of spending around $5,300 to equip each unit with batteries, Tesla could spend closer to $3,100. Sounds small? Not when we're talking about mass production of millions of units per year. This savings could translate into billions of dollars in savings, allowing the Model 2 to remain competitively priced without sacrificing profit margins. Another aspect that works in aluminum's favor is price stability. In recent years, lithium has seen price increases of up to 500% in short periods, creating huge headaches for automakers that depend on it. Aluminum, on the other hand, because it is widely produced and recycled, maintains a much more predictable price fluctuation. For Tesla, this could mean not only greater control over production costs, but also the ability to plan production increases without fear of being surprised by price spikes for raw materials. Recycling is another important asset. Aluminum is one of the most recyclable metals on the planet and can be reused with virtually no loss of quality. And best of all, the recycling process consumes only about 5% of the energy required to extract the metal from nature. This should allow Tesla to further reduce the carbon footprint associated with battery manufacturing, strengthening the sustainability discourse that is already part of the brand's identity. In the long run, this cost and abundance factor could make the Model 2 an extremely competitive car, not only in the electric segment, but in the automotive market as a whole. With an entry price of $15,990, it could compete with combustion-powered sedans and hatchbacks that have dominated the streets for decades. And since the maintenance cost of an electric car tends to be lower, the final bill for the consumer will become even more attractive. If the promise of ultra-fast charging from aluminum-ion batteries comes true, the Model 2 could transform the way people think about recharging an electric car. Today, even the most advanced models on the market still require 20 to 40 minutes to reach 80% charge on fast chargers. This new technology, however, is projected to deliver the same result in just 10 to 15 minutes in real-world use. It's a leap that brings the recharging experience much closer to that of a combustion engine car, reducing one of the biggest psychological barriers for those considering switching to an electric vehicle. The theoretical potential is even more impressive. Under ideal conditions and with adequate infrastructure, these batteries could reach full charges in less than 3 minutes. thanks to peak power reaching 1,000 kcal. While this scenario is far from everyday use, it serves as a showcase for how far this technology can go. And even if the Model 2 doesn't fully exploit this potential right away, the simple fact that it operates at charging speeds far above the current standard will be a significant advantage. The secret to this lies in the electrochemical characteristics of aluminum itself. Unlike lithium, which carries a single positive charge, aluminum carries 3, allowing the movement of more electrons in less time. This difference, combined with greater structural stability, should allow for fast recharges without the accelerated wear that typically affects lithium batteries when subjected to intense charging. In other words, users will be able to charge quickly without fear of drastically reducing battery life. Beyond speed, there's the issue of efficiency. Charging a car isn't just about filling the battery, but about doing so without wasting energy and without causing temperature spikes that compromise performance. Aluminum batteries, with their non-volatile and more heat-resistant electrolyte, should handle these extreme conditions better. This could be especially useful in hot climates, where loss of efficiency during charging is still a problem for many electric models. Another direct benefit of this faster charging will be the impact on travel routines. With a Model 2 capable of recovering a significant portion of its range in just a few minutes, long commutes will no longer be a logistical challenge. Stopping time at stations could be reduced to the point of becoming just a break to stretch the legs or grab a coffee, without the burden of long waits that currently keep EV drivers away. However, not everything will be perfect with this new technology. One point that could spark debate is the behavior of aluminum-ion batteries in extremely cold climates. Preliminary tests indicate that, below 20 degrees Celsius, charging speed will drop noticeably, and range could suffer an additional 10% to 20% reduction. For those living in regions like northern Canada, Scandinavia, or some northern US states, this may mean adapting routines or making more strategic stops on long winter trips. This limitation won't be exclusive to aluminum. Lithium batteries also suffer in the cold. But the expectation is that, as it's a new technology, the public will expect performance that's immune to these issues. Tesla, therefore, will likely work on complementary solutions, such as intelligent preheating systems, to minimize these impacts. Even so, it will be a challenge to convince consumers in cold regions that the Model 2 will be reliable in any season. Another factor to watch will be infrastructure. Even if the batteries support extremely high charging rates, the stations will also need to evolve to take full advantage of this potential. This may take time, and initially, many Model 2 owners will end up using chargers that don't fully utilize the fast charging capability. Tesla will likely announce updates to the supercharger network alongside the launch, but the transition will be gradual. There's also the issue of mass production. Creating a functional prototype in a laboratory is very different from manufacturing millions of units with consistent quality and controlled costs. Aluminum offers economic and plentiful advantages, but adapting production lines, training teams, and developing specialized suppliers will be crucial steps to avoid bottlenecks. Tesla has experienced similar situations in the past and knows that a delay in the production of a highly anticipated model could lead to frustration and market pressure. In the maintenance field, the outlook is promising, but still shrouded in uncertainty. The longer lifespan projected for these batteries could reduce costs and workshop visits, but since this is a new chemical on a commercial scale, no one knows for sure how they will react after years of intense use under varying conditions. It will be necessary to closely monitor the first batches sold to identify possible adjustments and improvements to the process. The design changes and cost-cutting measures expected for the Model 2 will also be part of this bold strategy to keep the starting price below $20,000. Tesla is expected to abandon some iconic elements found in the more expensive models, opting for a simpler yet more functional look. For example, the continuous LED bars on the front and rear, a hallmark of the brand's modern design, will likely be replaced by more traditional headlights, strategically positioned to reduce production costs. The idea will be to maintain Tesla's identity without spending money on expensive components that don't directly affect the vehicle's performance. Inside, the cost-cutting is expected to be even more noticeable. The panoramic roof, which gives a sense of spaciousness and sophistication, could be replaced by a metal roof, which is cheaper and offers better thermal insulation. The windows will likely be single-layer instead of double-layer, and the seats will likely come with fabric upholstery instead of the vegan leather used in other models. Even the audio system could be downsized from 15 to around 10 speakers, eliminating A-pillar units and simplifying the setup. Another point that should attract attention